Hello and welcome to the technical walkthrough of Algo Radio, the performance project supporting my thesis, semi-real-time use of Markov chains in algorithmic electronic dance music performance. Now in this video, I'm going to walk you through the hardware, the software, and the Ableton project and devices that are all relevant to the creation of this project. Without further ado, I'm going to walk you through the hardware to begin with. Here we have the full hardware setup, and I'm just going to talk you through this very quickly. So we've got two laptops that you can see, both Windows 10, both running copies of Ableton Live. We've got a DJ mixer over here, and we've got two MIDI controllers. Now, there's a big difference between the two laptops. This one on the left here is the generator laptop, and the one on the right is the performer laptop. Now, the generator laptop over here will algorithmically generate brand new musical sections to be used within a performance. Now, these can be edited, bits can be added, removed, and eventually, once it's ready for performance, it can be accepted. Now, once it's accepted, all of the information that builds that section is sent over to the performance laptop and stored in a list. Now, these sections can be recalled at any point if they want to be, and this laptop is connected to the two MIDI controllers. Now this is where I adjust the levels, apply effects, introduce new parts, and generally mix the moderated musical sections into smooth performance. Okay. Now in the middle here, we have the DJ mixer. Now the main purpose of this is so that we can provide a monitoring system between the two laptops. The audience during a performance will always be hearing the performance laptop over here, and they will never hear anything that comes out of the generator laptop. I'm using these monitor buttons here, and that allows me to listen to the output of the generator laptop through this pair of headphones. Okay, that allows me to have time to generate new material for the performance, and generally sort of keep an eye on what is going on between the two computers. Should probably talk briefly about the actual purpose of each MIDI controller. So this Behringer BCF 2000 is used in order to actually control the master volumes of each instrument. So number 1 here is for the drum machine, multi-Euclid. Number 2 is for a drum looper. Number 3 is for the vocal looper. Number 4 for the lead synth. Number 5 for the bass synth. Number 6 for the interludes. And number 7 for the algazoo, the algorithmically generated animal noises. Up here, the Akai APC40 is used primarily just for drums. So although the master level for the multi-Euclid drum machine is track number 1 on the BCF 2000, each individual drum has its own volume control over here. So we'd have kick drum here, snare, clap, hi-hat, open hi-hat, miscellaneous, etc, etc, and this one here as well. And finally, we've also got 8 dials along here and 8 pairs of buttons, which are all mapped to different audio effects, to turn them on, to turn them off, and to increase or decrease the amount that they're being used. So that's the overall setup really. We've got the generator laptop, the receiver laptop, or the performance laptop. We've got the DJ mixer, and we've got 2 MIDI controllers. Okay, so now that we've got an idea of how the hardware setup works, I'm going to start talking about the software. Now we're currently looking at the generator laptop, and this generator laptop concerns all of the generation of what will eventually become the moderated musical sections. So all of the algorithms generate new music over here. We can edit it until everything sounds good, until we're happy with it. And then finally, I can click this accept button up here, and all of that data will be transferred over to the receiver computer. Now there's 5 instruments. We've got the drum loop masher, the bass synth, the vocals, and the lead synth. We've also got the 5th instrument, the multi-Euclid. So this is a Euclidean drum machine containing 10 different drums. Okay, so just to sort of like speed things up for you, I'm not going to go through every single one of these control parameters. I'm going to go through them just for this drum loop masher here. So originally what I would do is I would load in the files first. I've already done that to save it crashing or something whilst I'm talking. And I'm going to start the transport on Ableton. Okay. Now, if I turn the volume up on the drum loop over here, we start to get some output. Now, first of all, we have got our preset. Now, this depends, this changes what sample is being mixed. So, if I randomize this button here randomizes the preset. We get different loops. Now, this box down here with all of the little matrix squares determines the Markov chain. Now, for example, over here, number 1 is a very simple Markov chain, just sticking at the first state. So there's not going to be any change of the loop, it's just going to be the loop as it is. However, if I put it to, say, Markov chain number 7, we're going to get some more complex sampling. Change the seed up here, or the pseudo seed, and I can change the Euclidean spacing. So this will determine, say, it's going to say that it's going to chop the sample 5 times within 16 steps. So let me put that up to 16. Put the speed here. I'm going to put it to 120. Now we're getting some fast different mashups of that drum loop. Okay, so hopefully you should tell a bit of a difference there between the seeds. And obviously I can go back to a seed if I like it. And that way it can be referred to at any point. So yeah, we've got the speed, we've got the Euclidean rhythmic side of things, so the pulses, the steps, and the rotation. And we've got seed length. So for example, if I liked what I heard, but I only wanted it half of it, I could go seed length 8, and then this is going to ensure that it's just a 8-note motif. Okay. We've got volume control here as well, obviously. Now that whole setup applies to more or less everything. So the vocals over here is an exact copy. So change presets, randomly generated. Got my seeds, the Markov chains, speed, etc. The bass and lead synth are slightly different. They've got some extra parameters, so let's have a look at the bass synth. So again, we've got our Markov matrix. This is going to give us all sorts of different melodies and bass lines. The main difference here is that we've got octave. So we can change the octave here. And I've also got pitch change. So just say, for example, I want to put it up 5 semitones. Easy. Okay. Now we've got our pulse, steps, and rotation. Now, once again, this is for Euclidean spacing of the sequence that has been generated. Okay. Now we've got duration as well, where I can choose how long it's going to be. Longer notes that way. We've got presets, different synthesizer presets. Now this is exactly the same, once again, as the lead synth. You can play through this, change a few parameters, and on each instrument you'll notice that in the top left we've got these little buttons here. Now that will completely regenerate the Markov chain that is being used, how many pulses, if there's going to be a different speed, etc. But one thing it will not change is which preset is being used. So just say I like the sound of an instrument, I can quickly hit that button and get a new melody. So for example, something like this. It changes everything, like the duration, the seed. Obviously that works for, say, the vocals as well. But this is only used in emergencies, really, because throughout that whole process of random generation, it also changes the Markov chain, which subsequently changes the collection of seeded sequences. So I would only ever use that in a situation where I'm not getting any material through any seeds that I like, and I just want a quick restart, click this button, I'll get something new. Now, finally, we've got the multi-Euclid interface down here. Now, this uses Euclidean rhythms once again, and the number of pulses is defined here. So currently, the kick is on 0. Now, if I switch that up, sorry, we've got the pulses up here. If I switch that to 4, where it's already at, this is the rotation, okay? So I'm going to put the volume up. Say I'll go to 8, we're going to get double time. 16, etc. And I can use this cross button here to just deactivate it. Now, I can go systematically through all of these and increase the volume. Now, certain of these I don't use much, like the cymbal, only occasionally. Now I can go neutral to get rid of all of that. Activate all to activate all. Okay. So that's essentially our 5 instruments. We've got the drum loop and the vocal that kind of acts as a pair. All of the parameters control how this original sample is cut up and chopped to create something new. And for the bass synth and the lead synth, again, acts as a sort of pair, but with some additional synthesizer parameters. And finally, our multi-Euclid down here. Now, probably the most used button in this entire interface is this randomize button here. This will generate a new set of parameters for each instrument, giving us something completely new. So if I just turn the volume up for everything. So that's not sounding great. Let's change everything. Might have to press it a few times to get something sounding good. So just say I like this, but I don't like the bass synth. I can now go ahead and edit that. So I like all of the rest. Let's change the bass synth. So maybe I just want to change the preset. Okay, so that sounds pretty good to me. Now, what I would want to do is give this a name, something that I can remember it by. So I'm going to call it, for now, test. How boring. So that is our section called test. Now I need to ensure that the IP address is correct, which it is. I'm using a crossover cable in order to transfer this data. So I'm using the auto configure IPv4 address. So just going to initialize that. And now that is ready to be sent as a new moderated musical section. I can press the tab key, or I can just manually hit the accept button up here. Now, a couple of extra things that I haven't gone over is the genre. This is almost like a preset for the drums. So just say that I've been making some techno and I want to switch it up a little bit, then this will kind of change the format that some of the drum basics using. So the kick and the snare might simplify it. So there's 4 on the floor with a snare, 2 pulses, 4 rotation, something along those lines. Just to demonstrate that quickly. Activate them all. I'm going to go techno. So you can hear we've got that 4 on the floor. We'll go trap. Now the kick is just at default. I think that's 6 pulses over 16 steps. So yeah, not a massive difference, but it does help when I want to switch things up a bit during the performance. And yeah, I can just hit that. So each of these little modules here references something in the Ableton project, a different device. So for example, I'll just talk through the drum loops over here. So all of these parameters get sent to a different device. Now that device will contain the drum loop masher. So over here, for example, we've got a UDP hub here, which sort of takes in all of the information, processes it, and sends it to the correct places. We've got the Markov device here, so this is the Markov for drum loop version 1.3.
Now, as you can see, all of this information here is the same as what we just had in the interface. We've got our Euclidean spacing. We've got our list of seeds, which is you have not seen yet. Here we go. So we've got seed number 0 up here, seed 62 down here. Now, I don't really use this during performance. This is simply how it's all processed. So this particular track, drum loop mash, if I solo that and went to the interface, turn it up, all of the magic is coming over here. This is the GUI. Now, I don't, again, use that during performance. I will use that in advance to create a new set of Markov chains and save them so that they can be used during the show. Now, once this patch here has created the seeds that's going to be used, spaced it, etc., sequenced it, that data gets sent to the drum loop masher. Now, this is the main instrument. The sound file is stored in here, and obviously you've got your index with a preset and a bunch of options here that that take the Ableton tempo, compare it to the original file tempo, and choose an appropriate playback speed so that everything's in time and whatnot. Okay. This is exactly the same for the vocal masher. So again, we've got the UDP hub where we receive all the information, and that gets sent out to a slightly tidier looking Markov device over here. Again, we've got our main GUI, we've got all of our receivers from the interface, and once again, it's sent over to the vocal masher. So if I click play, you'll see this yellow bar here that is determining which part of the sample is currently being played. So the sequence is applied to the actual point of the sample, as opposed to, say, the lead or the bass synth, which is actually creating MIDI data. So I'll have a look at that now. We've got our bass synth over here. So, a little bit different. We've got our UDP receiver for this as well on separate tracks. So UDP bass synth, UDP lead synth, and there gives you a little preview of the message that has come through, just so you can see what the data looks like. So now we're going to have a look at the bass and the lead tracks. Straight away you will see the familiar Markov for lead, Markov for bass. Now these work very similar ways to the drum loop masher and the vocal masher's instance of the Markov devices. The only real difference is that these create MIDI messages. So, for example, we can see yellow dots jumping about here, notes coming out. Okay, so instead of actually determining where in a sample it's being chopped, instead it is actually creating like velocity messages, pitch messages, etc. And that is going straight into our instrument rack here. Now the instrument rack is storing many different devices, many different instruments, but only one of them will be played at once. Now the way that we control this is with this chain selector over here. So, for example, if I pop desired preset 1, this is going to send an API message over to the instrument rack to determine which device is activated. So if I click play here, you'll see the instrument number 1 is now playing. But if I go number 5, we're now receiving audio output from boom sub down here, device number 5. Okay. Now all of the other devices will be deactivated, as you can see here. This was essentially a way of getting around CPU problems and generally creating a system that allowed for optimum amount of diversity in terms of synthesizers without using lots of CPU. Okay. Now this is applied in the exact same way over on the lead. So we've got our chain selector, got our Markov device, which is producing the sequence, and that is heading straight into our instrument rack. Okay, so that's more or less everything in terms of the generator GUI, the workflow of the actual Ableton project. The only things that we haven't really covered here are groups. Now, every time I click the accept button, so just say I like this particular section, it's going to add it to a list. Now, just say I've started off there on the root note. I could say, right, for the second version of this particular section, I want a transposition of 5 semitones. I also want to change this preset, and now I want to accept that. And then I want to go to different preset, maybe 3, accept, 2, accept. So I've now got 4 different versions of the same section that have been sent to the other computer. Now, in order to group these, all I have to do is click this new group button. And what that will have done is said to the receiver computer, presets 1 or sections 1, 2, and 3 and 4 can now be all put into the same group and sequenced accordingly.
Okay, so just before I go into the receiver laptop, let's just have a look at how the semi-real-time concept actually works. So I've found something that I like. I'm going to change it. Okay, so I like that section. I'm ready to make it a moderated musical section. So I'm going to give it a name, MMS, and I'm going to hit the send button. Now, let's have a look over here on the receiver laptop. We will see it pop up in this menu. So 1, 2, 3. You can see that we now have the MMS section ready to be used. So now, if we have a listen to it, it should sound exactly like the one coming out of the generator laptop. The only difference is that it will have some generated audio effects and generally sound a little bit fatter. So let's have a listen to that on the receiver. On the generator. Hopefully you should hear there 2 very similar sounding sections, but the receiver obviously made it sound a lot better. Lots of effects. I'm now just going to demonstrate how you would apply that to group sequencing. So I like this section, but I want to say have a bit of a chord sequence about it. So what I'm going to do first is I'm going to say, right, start with 0 pitch change, accept. Then I'm going to go pitch change of 12 semitones, accept, 5, accept, and finally 3, accept. I'm then going to click new group, and it's going to group all of those sections together, ready to be sequenced. So we can already see here that we've got our 4 sections, all there. But if we look in the group box here, you can now see it says group 1 contains sections 0, 1, 2, and 3. So what I'm going to do is I'm going to click Auto Preset Changer here, and I'm going to select Group 1. And now, when that starts playing through, you should be able to hear the transposition. Went to the bass and looked at the transposition, we'll be able to see that for ourselves. Okay, so that is essentially how you would move a section from over here, from the generator laptop, over to the receiver laptop. How to group them, sequence them, and then of course perform with them using these controllers. Now let's have a look at the receiver laptop and how the flow of that works. Okay, so we are now over on the receiver computer. Let's have a look at all of the tracks and the interfaces that we've got over here. Now, the main track that I would always have open when I'm using the receiver interface is the interface track. We've already seen this over here. It's where we store all of our MMSs. It's where we can group them, sequence them, etc. So for now, I've just got a few preloaded in. Now, what you'll notice is we also have an extra interface over here. If I click open, you'll recognize it from the generator computer. Now, generally I shouldn't have to use this. Obviously, by using semi-real time, I'm able to moderate the output on the generator laptop, send it over, and that way I don't really need to change anything over here. However, this interface is available for little emergencies, or if I just fancy a little improvisation during a performance. A little bit risky, obviously, because that, for that time being, you're not using semi-real time anymore. But it's certainly nice to have the option, and can sort of like increase my sort of like feeling of flow state, having the option to use this, Right, so I'm going to go through what we've got here. I've already shown you how this all works. You can manually select moderations if you wanted to. Apologies for the CPU problems I've got here. Right now, a lot of things running at once. And yeah, you can choose your groups. I've actually queued up 2 lots of groups over here. So we've got group 1 is preset 0, 1, 2 and 3, and group 2 is 4, 5, 6 and 7. Okay. So multi-Euclid, straight away you can see that I've got a little interface here for every single drum. Now obviously once all of the information is unpacked from our MMS, then it is loaded into here. I'm just going to quickly show you where the information is unpacked. That comes out here, the UDP receive hub. I'm not going to open it up, it's going to crash everything, and it's pretty messy patch, but you can see here all of the data that has come through, unpacked and sent to the appropriate places. So yeah, the first is our multi-Euclid. Each of these faders can control the volume and been mapped to one of my MIDI controllers. We've got the drum loop masher. Now you'll notice a lot of similarities here. We've got our Markov device, we've got our actual drum loop masher. Now these are literally like clone copies over from the generator. The only difference is that instead of using the interface to control these, the data that comes from the generator laptop, unpacked by the UDP patches, is then just like sent over to these clones. So if I decided to say, I said like, right, I want to change that, then as soon as I say, right, I want to recall section 1, then straight away it's back to the original index. So there's no point trying to change these really during a performance. Everything is handled by the interface track. Okay, so yeah, those are just clones. We've got a few bits of effects going on here: compression, beat, repeat, and more. Vocal mash, exactly the same. We've got our Markov device over here. We've got our vocal masher, and once again, all of these parameters, they're just receiving data from UDP and loading it depending on which section it's chosen. Okay. We've got loads of effects going on here, all sorts of things for different reasons. So that's our drum loop and vocals. We've got our bass and lead, once again, works in the exact same way. We've got, again, a clone copy of the instrument racks, because that way we can ensure that everything's going to sound the same. We don't want any little differences going on there. So yeah, we've got our chain selector, got our Markov, and then notes coming out, and it is affecting the instruments over here. Same for the lead. Only thing that is kind of weird about this project is you might notice there's a lot of empty tracks, or tracks that I'm not discussing. For example, we've got an empty audio track over here. We've got some old track that I used to use in early prototypes. Again, another one, empty track. The reason I've got all of these here, it's all to do with the API. Now, when I need to send a message to, for example, the instrument rack on the bass synthesizer, Ableton needs to know what track number that is. So I need to send a message to API saying something along the lines of, go to track number 11, go to device number 2, and change a parameter to this, or X, Y, or Z. Now, if I deleted one of these tracks, as I've just done there, then everything changes. These messages stay the same, but the locations of all of these tracks do not stay the same. So it can really mess things up. Now I don't want to do that, so I've just left all of these kind of like dummy tracks in. They don't do anything more, but they don't use any extra CPU anyway, so it's not getting anyone's way. It just makes sure that everything remains nice and stable. Okay. Now, Animal Clips is a track. There's quite a few tracks, in fact, that we do not use at all in the generator, and they're just to kind of like provide extra sonic details, little generative instruments to keep things interesting during interludes. Animal Clips is one of those. So if I click begin over here, I've already messed everything up by deleting that track from earlier, so I'm going to do a quick undo. See exactly the problem I was talking about. So Animal Clips essentially is a instrument designed for algazoo that I talk about in the thesis, and from an early prototype I enjoyed the sound of the Markov chains affecting different animal samples, sort of like matching them up and whatnot. So I basically sort of curated a load of recordings of exactly that. You can hear how it sounds over here. So if I click play, got dogs, horses, chickens, more horses, there's cats and all sorts of different animals. Now, what's going on there, you might have noticed, is these clips are being randomly triggered, every single bar. Now, the way I've done that is by using a device from Maxwell Live called Random Clip Launcher, and I've modified it slightly. So normally you would have to click this button in order to randomly trigger one of these clips, but I've got it happening every bar based on Ableton's transport. You can choose the range, so I'm saying right there's 24 clips here. Start on clip number 1, and then this button here will just randomly generate or randomly trigger one of those clips. It's all BPM synced and everything, so you know, if I increase my BPM, no problem, it's all going to get sped up. Okay. So that is essentially used. Stop. So that's essentially used during main performances, and it's also used. Oh my gosh. Let me just pause that for now. So yeah, that is used for during MMSs and interludes, but there's nothing to do with the generator laptop with that. So you know, the clip that's being launched isn't affected by the MMS coming from the generator. It's more just random, and I can intervene if I want. I could turn off that random clip launcher using my MIDI controllers, and yeah, choose one that I like in particular. What else have we got? So we've got a whole interlude group of tracks over here. Now these are used whilst I'm preparing additional moderated musical sections, and it sort of provides me with time to know that everything's going to keep on working, give a bit of variety. No one's going to get bored with like really repetitive sections, and on top of that it's kind of exploring a different area of sonic material, so it changes things up a little bit. Now if I open up this group, we've got several different devices going on here. So for example, Auto Samsara. Samsara is a granular device that I'm using, and you might notice there's a lot of LFOs all stacked up over here. This is essentially to try and emulate how a human would use a granular synthesizer. So you know, they'll be changing the start position of the grains, the size of the grains, how many voices, the spray, etc. So all of these are mapped to different dials and control parameters on the granular synthesizer. So it essentially allows for these generative kind of things going on. So if I play that, I need to turn the volume up on my interludes as well. Now the samples that are loaded into this particular granular synth are radio voices, so sounds from talk shows, from news reports and the weather, stuff like that. So yeah, it's going to kind of like generally not sound clean. It's going to be kind of like rapid exploration of it. But we've got a clean version over here. Now this is using the random clip launchers as well, as you can see. And if I turn the volume up over there, click play, you'll notice that it's triggering these clips every bar once again, but it's clean, it's not going through granular exploration. And I think the pair between granular version and a clean version works pretty well. So yeah, those are all once again radio samples, the same as one that are loaded into the granular synthesizer. On top of that, we have got some extra granular devices. So this one here is loaded with drum sounds, and this one here is loaded with samples from past performances that I've done with Algo Radio. So it's kind of made so that it can create this generative soundscape of radio sounds, audio snippets from past performances, so a little bit of music and some drums to go with it as well. In addition to that, we've got the clean version once again, so randomly launched clips, and these clips are full of samples from my performances. And once again, yeah, this is the clean version. So the granular version, you might not actually be able to hear the music very well. It's more like little sonic glitches and details. But over here, I can ensure that there's some kind of like audible music interweaving with all of the radio sounds, etc. So yeah, it keeps it musical in a sense. Now, there's more or less everything. One thing that we haven't looked at is tendency masking. So let me just show you this quickly. So if I scroll along over here, once again I've got loads of dummy tracks over here that we don't need to worry about. I've got the drum group track over here. All of the plug outs from the multi-Euclid device are sent here. As you can see, everything's kind of got different audio effects. I've got compression and the bass boosted on the kick drum, but on the snare, you know, I've got the mids taken out and a bit of reverb. On the hi-hat, I've got the high increase, the treble, a bit of reverb. So yeah, this just allowed me to separate all of it so it doesn't get all claustrophobic and compressed, and also allows me to add audio effects to each individual drum. Now, as I was saying, we've got tendency tracks over here. Now, all this does essentially is applies a tendency masking patch to the macro controls of synthesizers. So if I turn this on, you'll notice that this kind of scanner is skipping around. Now, this is trying to emulate if a human was to get a MIDI controller and explore sounds in real time. If I head over to, so this is for the tendency masking of the lead synthesizer. If I head over to the lead synthesizer, you should be able to see the macro control is being automatically controlled by that tendency mask. So it's going up and down, but only within the range that I've set it. If I turn that range down, then it should be a little bit more subtle. So let's make the range just like 10, for example. If I go back to the lead once again, you'll see that the macro control now is moving a lot more subtly. Now, that might look like a better option, but generally speaking, it can be a little bit less noticeable. So usually I have the range set a little bit higher. But I do change this during performances depending on which synthesizer is playing. And a lot of the times it is more relevant, more appropriate to just turn it off and control it with a MIDI dial. So now that it's off, if I go back to my lead synthesizer, yeah, I can now manually change that macro control. Now the macro controls are mapped to all sorts of different control parameters depending on the instrument. So this first instrument here, you can see it's mapped to the filter cutoff, the tone and the delay. Go to the second one, just the filter frequency and the delay this time. After fade, it's two different filters. So every single instrument here has different macro mapping. And even though the device is off, if I turn that macro control, you can see that it's affecting the chorus and the filter cutoff on this example. So yeah, that was generally a way for me to control and affect the properties of synthesizers on a large scale. So every single instrument just with one tendency mask. So yeah, it was a really important thing to kind of offer extra variation during performances, kind of acting in the same way that interludes does. So, you know, providing extra little sonic details whilst I'm busy, creating extra MMSs or editing other things in the interface. Okay, so thank you for watching this tech walkthrough. As a little bonus, this is the UDP patch that I was avoiding showing. It is just absolute spaghetti, as you can see, but yeah, this is where the whole unpacking process of data happens. This is where it all happens, and yeah, it's all in one place. It's Easy to debug, believe it or not, using presentation mode. I've got all of the parameters up here that I can identify whether there's a data lapse or something along those lines. But yeah, thank you very much for watching, and I hope this helped you understand how the whole system works in general. And yeah, enjoy the rest of the thesis and the rest of the audio recordings and video recordings. Thank you.